Jessica. So we have Dr. Jessica Feldman. She's a early career researcher in the CFM and specializing in circular economy analysis and system modeling. And she's doing in this part of the both No Waste project and Simple Hub. So now, floor is yours.
Thank you. I'll share my screen. So just checking, is the slides up on the screen working properly? Can you give a thumbs up, Pradeep, if it's working? Okay, I can hear you back. Thanks. Okay. All right. Well, good afternoon, everyone, and thank you for coming along to my presentation. So today I'm going to provide a brief overview of circular economy and then discuss an example of how circular economy analysis is done using glass waste as the example. So to start off with, circular economy may be a term familiar to some or completely new to others. And if it is something you've heard before but still don't quite understand it, then you're not alone, as there is apparently 221 different definitions for circular economy that are just from the last 6 years, from 2023 to 2018. So it's something that's quite difficult to define, and there is no consensus yet. But if you look over here on the right, this is showing the general concept of circular economy, and you can see how it forms that circle or that cycle where its materials go through the supply chain, but instead of being disposed of at end of life, they return back into that supply chain to be used for as long as possible. And the core principles of circular economy include that less raw materials should be used, less waste and emissions produced, and importantly, to maintain the value of the materials and products for as long as possible, as that really encourages and enables that continuous cycling to happen. And you may have heard of the 4 Rs: reduce, reuse, recycle, and recover. These are all common strategies that are used in circular economy. Now, as you can imagine, and you can see here all the different steps in the supply chain that are involved, achieving circular economy is something that really will require system change to actually achieve this. So it's a real complex problem, and it's not just a simple, we make one change and then we can achieve circular economy. So globally, there's been a big push towards circular economy, mainly because of the UN Sustainable Development Goals. And Australia, like many other countries, has committed to achieving this by 2030. But unfortunately, when we look at metrics like the circularity rate and other metrics they use to measure progress towards the Sustainable Development Goals, Australia is quite far behind the global average. And in this figure here, which is showing the rates of recovery of some of the more common materials over time, you can see that, and sorry, I'll just define for those not familiar, recovery is just when a material reaches end of life. If it's recovered, it doesn't go to landfill, and instead it's reused, recycled, or goes into another product. So you can see in this graph here that over time, recently, we are stagnating or even slightly decreasing in our recovery rates. And we're definitely not on track towards achieving the goal of 80% recovery for all materials by 2030. So to try and understand why Australia is struggling in this area, I recently published this paper called Circular Economy Barriers in Australia. And it's a systematic review that looked at the papers that have been published from 2018 to 2023 that focused on Australia and circular economy and discussed these barriers. So the number one barrier that was most common across all industry sectors that were reported on was standards and regulations. So what this means is that the current standards that define how a product is made or how a product is disassembled and recovered, and the regulations that police that as well, are not supportive of a circular economy. And this is a common theme across many different industries. Other common barriers are, of course, economic factors like high transport costs, not enough government incentive, and also missing or inaccurate data, and that circular economy is not prioritised by business. So in this paper, I also looked at the industry sectors that were reported on in Australia and their most common barriers that they found. And this table here is showing the values, the values are the percentage of industry papers that reported that barrier out of the total for that industry. So today I'm just going to be focusing on construction and demolition waste, as that relates to the glass example I'm going to go through soon. And the number one barrier for construction and demolition waste is that it was not prioritised by businesses in this industry sector. So what this means is that factors like business time constraints, rigid organisational structure, and also just the risk-averse nature of businesses in this industry mean that circular economy is something that's not prioritised at all. And also economic factors are very important. So it's not cost viable or lacking government incentive to actually trigger this change to happen. So for the remainder of this presentation, I'm going to be focusing on an example of circular economy analysis, and I'll be focusing on glass waste in Queensland. So out of all glass waste in Australia each year, about 90% is glass packaging waste. This forms a really large portion of that waste. And at end of life, this glass waste has two common pathways in Australia. It goes back, recycled back into glass bottles or as a sand replacement. So when glass is recycled back into glass bottles, this is glass is 100% recyclable, so which means it doesn't degrade over repeated recycling. Plastic, when it's recycled over time, the material loses some of its properties, and eventually it can't be reused again as a packaging plastic, whereas glass doesn't have this problem. And because of this, recycling glass back into glass maintains the value of that glass material. And you can see that the value of virgin materials into new glass packaging is quite high. So this is quite a high value application for that glass waste. Whereas glass sand is classified more as downcycling, and that's where we take the glass waste, crush it up into a really fine, similar to sand. It looks like sand because sand has similar chemistry. And it's used commonly in things like roads, concrete, and other similar applications as well. But it's classified as downcycling because it lowers the value from if it was recycled back into glass. And importantly, at end of life, it's not able to be recovered as glass. So once it's crushed up as this sand and put into another product, we can no longer get out those small pieces of glass and make glass bottles again. And you can see that the value of sand is significantly less per tonne than into glass packaging. So right now, the answer seems quite simple. Glass recycled into glass bottles is the better choice. Why would you ever do the other one? But the big advantage of glass recycling as a sand replacement is that the amount of acceptable contamination, which is the amount of other materials that can be in that glass waste stream, is much more lenient. So just naturally, when glass is collected in your recycling bin and taken to a material recovery facility, it's going to be exposed to a lot of other materials. And for glass bottles, another important factor is the size can't be less than 8 millimeters. So naturally, because glass is breakable, during collection and sorting, it breaks. If it gets too small, it can no longer be put back into glass bottles, and they have to find another application for it. And glass bottles also requires colour sorting, whereas glass sand doesn't. So because of these different requirements for sorting, the glass waste is treated differently during collection, sorting and processing based on where it's going to end up when it's a product again. So starting with the bottle use phase, so this is when you have your bottle of soft drink or something like that. You have two choices. You can either put it into just your recycling bin or the landfill bin, or you can take it to a containers for change deposit location. And this is where you get the 10 cents and then they take away that material. So the great thing about containers for change is that the material is already sorted, it's very clean, and there's much less breakages. So this can go straight away to being a high quality glass cullet, which can be used to be recycled back into glass bottles. Whereas glass waste that goes through your yellow recycling bin has a much more complex, costly, and challenging pathway to get through. So it goes, once it's collected, it goes to a material recovery facility where all the material is sorted, and they'll separate out that glass waste into the glass cullet, which is the larger above 8 millimeters in size, and anything smaller is classified as glass fines. So the glass cullet is still contaminated at this stage, and it's mixed color. And then it can go to another facility called a glass beneficiator, and there it is, the contamination is removed and it is color sorted and it can become a high quality glass cullet. Whereas glass fines, they contain a lot more contamination than the glass cullet, because not only do they include all the small particles of glass, they also include all the small particles of plastic, organic, dirt, and other things that are just really hard to separate out. And some material recovery facilities, or MRFs, or MRF, as I'll call them from now on, they have their own glass cleaning and crushing facilities, so they can produce the glass sand there. Otherwise, they have to send it away to another facility for this to occur. And you can see throughout this diagram as well that at multiple steps along the way, glass can be lost to landfill. So in circular economy analysis, it's important to understand the flows of the waste material and factors that are currently impacting its recovery. So what I've done next as the next step, and to create this figure as well, is to look at the flows of glass waste in Queensland, and this is from 2020 to 2021. And based on the industry and government reported figures and efficiencies for collection and sorting, I've produced this figure here. So we know that there was 123,000 tonnes of packaging glass that was sent to landfill in 2020 to 2021. And just naturally, because not everyone puts the glass into recycling, or in some locations, there just isn't sorting facilities available, especially the more regional and rural areas. This is classified as uncollected glass waste. For the glass that is collected as recycling, there's always going to be some sorting loss, as the naturally some glass is lost as landfill and not separated out. And what I found at the end of doing this, and this is based on the Australian sorting and collection efficiencies, is that those efficiencies didn't match up to how much glass we were actually recycling in Australia or in Queensland. So there was a large amount, almost 50,000 tonnes of glass, that according to those published efficiencies should have been recycled, but instead was disposed of as landfill. And from talking to MRF operators and industry, a lot of what we're hearing is that they have this glass product that they could be separating out, but there's just no one there who wants it, no one there willing to buy it. And this is why I've classified that as no market. And that's a real opportunity for circular economy, because it's something that's, the technology is already there, and we can get that if we can find a use for it. So I also looked at the glass that was recycled. So as I said earlier, there's the two main pathways, container exchange or MRFs. And of all the glass that was recycled back into glass packaging, it all came from container exchange, the high quality cullet. And that that pathway I showed you earlier, where they produce the glass cullet, it goes through this process, is something that's not really happening. And you can see here as well that high quality glass cullet from container exchange, in some cases, almost 20,000 tonnes, they aren't even able to recycle that back into glass bottles, and it's going into other applications, which suggests that either there's some other factors happening, or the capacity to produce recycled glass into glass bottles in Queensland is not sufficient to meet that amount yet. So as I noted earlier, the economic barriers to circular economy are really important to calculate and address when you're trying to propose that something is a solution. And this forms part of circular economy analysis. So over here on the left, this is just looking at the values of the material when it goes through these different pathways. So containers for change, the glass cullet that's produced through that, which is free of contaminants, colour sorted, it's about $119 per tonne. Whereas the MRF glass cullet that they produce, which is more contaminated, they actually have to pay to get rid of it, even though they've gone through all the effort of sorting it into that glass cullet. So they have to pay about $30 per tonne, which might sound like a bad deal, but when you compare it to the cost of landfill, it's still much cheaper for them. Glass beneficiation of that highly contaminated glass cullet is about $150 to $200 per tonne. And it's assumed also, that containers for change glass that's collected will also have to go through some processing, which based on the different purchasing prices at those glass beneficiators is assumed to be about $50 per tonne. You can see that it still is quite economical to go through this way. And the value of the glass cullet at the end when it's sold to a glass bottle manufacturer is between $470 to $620 per tonne. Whereas sand replacement, the MRFs have to pay more money to send it on to someone who will use it. So it's about $50 to $80 they'll pay, which is still less than the landfill levy. And some of these MRFs do the cleaning themselves and crushing, and this still is reported as a negative figure. And the value of this glass sand is about $30 per tonne. So a big difference there. But this is just one economic factor, and another big one, which is one of the second highest barrier to circular economy in Australia, is transport distance. And this figure here is showing Queensland, obviously, and also all the glass crushing facilities, which are these little icons here, and the one and only glass bottle manufacturing facility in Queensland, which is down here in Brisbane area. So what this means is that if you're recycling glass back into glass bottles, then the cost just from transport alone can really completely prohibit that being an option the further away you are from Brisbane. And I've put here the cost per truck to transport about 31 tonnes, and also the cost per train, and also the carbon emissions from this transport. So you can see, particularly from Townsville and Cairns, not even including the cost to sort and crush and process the glass, it's already not economical just based on the transport cost. So I've given you some factors, some for glass sand, some for glass bottles, but what actually is the choice that is best? So I haven't discussed today the environmental impact, but for every 10% of cullet used for glass cullet into glass bottle manufacture, it saves about 3% of energy and a carbon reduction of 5%. And that's because the temperature that they use in their kilns to make the glass bottles is reduced when they use glass cullet. And the profit to glass beneficiation ranges from about $300 to $450 per tonne, excluding transport, of course. And another big positive is that it can be recycled indefinitely. But for glass sand replacement, something that I haven't really touched on and is really important is that when I said earlier how glass cullet that's smaller than 8 millimeters is classified as glass fines and can't be used for glass bottles, the amount of glass in MRFs that is this glass fines is 30 to 50% of all glass that goes through. So this is a really large amount that wouldn't be able to be used for glass packaging and would end up in landfill if we didn't have that glass sand option. The MRF still saves about $25 to $55 per tonne to sell the glass sand compared to the cost of landfill. And another big benefit is the glass material can be used locally, avoiding transport costs and emissions. And I haven't discussed environmental impact of the glass sand, and that's because they're still developing the standards and the standard processes for this. And that's something that needs to be done to have an accurate life cycle assessment. And just briefly, I want to touch on that this is the current situation, but in 2025, Visy is updating and building a new glass recycling and remanufacturing facility in Brisbane area again. And this will allow for a much higher amount of glass bottles to be recycled and manufactured each year, and this will disrupt the market, most likely. So just some other considerations for circular economy that determine whether putting this glass waste sand into other materials will have is a good idea, or whether it will have other immediate or long-lasting effects. And these are also important to consider. So is construction affected by that changed material? When you add in glass into these products, like concrete or asphalt, how is the properties of that material affected? And also, is the amount of water and other materials used in the mix changed? Because that could affect environmental impact. Other health and safety considerations and lifespan and maintenance requirements. And I've just got a picture here of our student Malwinda, who's doing a project in this area looking at how glass impacts the circularity of concrete and asphalt. And this is really important for answering some of these questions. So to finish my presentation off, I just wanted to talk more broadly about, more broadly to explain when circular economy analysis should be used. So the example I focused on today is waste glass, which is quite broad because I looked at the whole state of Queensland. But we also do this type of analysis for specific process or product development changes. And that completely changes how the analysis looks like because we have a lot more data, we can be a lot more technical. So circular economy analysis is suitable for projects that are investigating a change in material or process that could potentially change the environmental impact from the standard process. So if your project is saying it has an environmental benefit, simply using a waste material doesn't guarantee that benefit, and it doesn't guarantee circularity either. So it's important when you're making these statements to do this more advanced analysis. And as part of CFM Simple Hub and also the No Waste Pilot Precinct, we're eager to collaborate with other groups in the centre and more broadly in the university to help you with the circular economy analysis. So this is something that my team is working on, and we're eager to partner with you to do this kind of analysis for you as well and add value to your projects. So this is just a snapshot of some of the data and information required, and we'll help you with that as well. So this is just the data references I used, and thank you everyone for coming along today.